Welcome to part 1 of derivatives of trigonometric functions. In this video we're going to start to learn how to find the derivatives of trig functions, and as a first step we're going to find the derivative of sine of x. And the reason we're doing this is that once you found the derivative of two basic functions, you'll be able to find the derivative of any other trig functions just using the chain rule and the product rule. So the first basic function is sine of x, and the second one is cosine of x. Those two are the basic functions. So the goal for this video is to find the derivative of sine of x. That is our goal for this video. So we're going to use a little trig identity. We're going to use this identity that says that the sine of a plus v equals this formula. I'm sure you remember this identity, as it is one of the most basic identities. So let's now consider the function f of x equals sine of x, and we're going to find its derivative. And the only way I can think of how to find the derivative is to use the definition. So we're going to try that. We're going to use the definition of the derivative, that is this one. I'm sure you are very familiar with this definition already. So here we have f of x plus delta x, and in this case we're considering f of x equals sine of x. So we replace here and we get sine of x plus delta x minus sine of x. And sine of x plus, and here we can apply this identity. Here we have x plus delta x, and that is a plus v. So we can replace here. Here is where we apply this identity to get this limit. So now we only have a limit problem. We only need to solve this limit. And the first thing that you should notice is that we can factor the sine of x here. We can take the common factor sine of x, and we multiply and we get sine of x times cosine of delta x minus 1, plus the other term, that is sine of delta x plus cosine of x. And now we can separate this limit into different limits like this, and notice that we can take the sine of x out of the limit sign because we are taking the limit with respect to delta x. Delta x is the variable that is approaching 0, so sine of x is a constant. And the same thing with cosine of x here. We can take it out of the limit sign because it is a constant with respect to delta x. So here, notice that here we get sine of delta x over delta x, and that is what I call the fundamental trig limit. And I wrote a whole page about this subject, and this limit, you prove that this limit equals 1 using the squeeze theorem. And you can check out the page on the squeeze theorem, and it'll say why this limit equals 1. And now we're going to show that this other limit here equals 0. So we'll get that this equals 0, so the derivative will be cosine of x. So our goal now is to show that this limit equals 0. And the first thing we can do is to swap the signs in the numerator like this. You can write 1 minus cosine delta x, putting a minus 1 outside of the limit sign. And why are we doing that? You'll see in a moment. We can multiply this and divide by this expression, this trig expression. Notice that is the conjugate of this expression. So perform the product in the numerator, we get this difference of squares. We get 1 minus cosine squared of delta x over 1 plus cosine of delta x in the denominator. And notice that here this expression is just sine squared. So here we have sine squared, and we can separate that into two factors like this, and even separate in two separate limits, and we get sine of delta x over delta x times sine of delta x over the other factor in the denominator, that is 1 plus cosine of delta x. And here once again we get the fundamental trig limit, and this limit here will approach 0 because sine will approach 0 and the denominator will approach 2, so this limit equals 0. And with this we have shown that this limit is 0. So finally we get that the derivative is cosine of x, and another way to write this is to say that the derivative of sine of x is cosine of x. And this is the first basic trigonometric derivative. That's all for now. Thank you for watching, and see you next time.